Okay, and looking at determining the inverse of a 3 by 3 matrix, again, for a matrix to be invertible, okay, among the characteristics is that the number of rows should be the same as the number of columns, okay. And here we have for the given matrix A, okay, we have 3 rows and 3 columns, thus we have A to be a 3 by 3 matrix. And looking at the elements going row by row, okay, so you have 1, negative 1, 1, 2, 7, 4, and negative 4, 0, 3. And looking at the determination of the inverse of this matrix, again, we have going back to our formula, okay, we have the product of A and the identity is equal to the identity times the inverse. Okay, so for A times I, okay, so again, I have the elements from matrix A, and again, for a 3 by 3 identity matrix, again, you have ones to run diagonally, okay, and where we have the rest of the elements to be 0. And looking at what we have here, okay, for A times I, okay, so we have in the setup, now again, I'm going to perform the Gauss-Jordan elimination to get the matrix down to the reduced row echelon form. Okay, so I want the first column to be 1, 0, and 0. So looking at adjusting, I'm going to make the 2 into a 0, and likewise with negative 4, have that converted to a 0. So looking at performing, okay, the simultaneous operations, okay, so I'm going to take the second row elements and deduct twice the elements of the first row. And for the last row elements, I'm going to add 4 times the corresponding elements from the first row. And so upon doing this, okay, so the second row is going to transform to 0, 9, 2, negative 2, 1, 0. Last row is transformed to 0, negative 4, 7, 4, 0, and 1. Okay, so the first column is 1, 0, 0, and I want the next column to be 0, 1, and 0. And I can change the 9 to a 1, okay, by dividing by 9 or simply multiplying by the fraction 1/9. Okay, so leaving the top and bottom rows as they are. Okay, so I'm going to divide, okay, the second row elements by 9. Okay, so here I'm going to have 0 followed by the desired 1, and I have 2 ninths, negative 2 ninths, 1/9, and 0. Okay, so I have 1, 0, 0, and from the second column, okay, I want to change the negative 1 as well as the negative 4 from the bottom to 0, okay. And so for what we have in following through, again, to get the negative 1 at the top in the second column to 0, I'm going to add the second row elements to the elements in the top row. And from the bottom row to change the negative 4 to 0, I'm going to add 4 by taking the last row elements and adding 4 times the second row elements. And so for what we have in the follow through, okay, so the top row we have 1, 0, 11 ninths, 7 ninths, 1/9, and 0. And for the bottom row we have 0, 0, 71 over 9, 28 over 9, 4 over 9, and 1. So if you notice, I got 1, 0, 0. Second column I have 0, 1, 0. And I want the last column to transform to end up at 0, 0, and 1. And right now, for what I have with 71 over 9, I can change that over to 1. And that'll be done by multiplying by the unusual fraction, 9 over 71. So multiplying the bottom row by 9 over 71, okay, we're going to have the transformation to 0, 0, 1, and then we have 28 over 71, and I have 4 over 71, and then I have 9 over 71. Okay, and again, so I have 1, 0, 0, 0, 1, 0, and the 11 ninths and the 2 ninths from the third column I want to be changed over to 0. So in carrying over what we have here, okay, so I'm going to take from the top row elements, I'm going to take away 11 ninths of the corresponding elements from the last row, and simultaneously, okay, to change the 2 ninths to 0. I'm going to take the second row elements and deduct 2/9 of the corresponding third row elements. So we have in the development, okay, in the process. Okay, so I'm going to have the top rows going to be changed over to 1, 0, 0. Then I have 21 over 71, 3 over 71, and negative 11 over 71. Middle row I have 0, 1, 0. Then I have negative 22 over 71, 7 over 71, and negative 2 over 71. And notice, okay, we have the resulting reduced row echelon form. And notice we have on the left, okay, we have the developed identity matrix. And for the 4th, 5th, and 6th columns, okay, making that into its own matrix. Okay, this is going to be in reference to, once again, the inverse of matrix A. So the inverse of A, okay, is going to be consisting of these elements. And you can also write this in fractional form where we have 1 over 71 times, and going row by row, 21, 3, negative 11. And then middle row I have negative 22, 7, negative 2. And for the last row I have 28, 4, and 9.